In Chapter 10, we will discuss creating functions. By the end of the chapter, you should be able to create your own functions, pass information to a function, use default values, and return a value from a function. Creating and using simple functions. Functions are often used to eliminate repeating code that is used frequently. Say that you had a block of code that's used several times in a script. You could duplicate the code, basically rewriting it each time it's used. This would cause a problem if the code ever had to be modified. It would have to be changed in every place that it was duplicated. A better way is to write the code block in one place in a function, then call the function each time the code is used. This saves time in that the code is only written once and would only have to be changed in one place, and it makes the program easier to understand. Functions are not run automatically. The function has to be called to run the statements within the function block. The syntax for creating a function is shown on the slide. Start with the function keyword, then give the function a name. After the name are the parentheses. This is where the function arguments will go. We will cover function arguments shortly. Then an opening curly brace to start the block of code for the function, then the code statements, and finally a closing curly brace to end the block of code. You can also see an example of a function on the slide. The function name is whatever, and the function code prints the string whatever. Notice how this example matches the syntax above. Naming functions is similar to naming variables. Use all of the rules except without the initial $sign. The $sign indicates a variable, so don't use it when naming functions. Pick meaningful names. The name of the function should represent what the function does. Don't use spaces in the function name. Use an underscore to represent a space. Unlike variables, function names are not case sensitive. You should pick a naming scheme and stick with it. For example, don't use uppercase in one place and lowercase in another place for the same function. Any valid PHP statements can go inside the function code block. Every PHP statement must end with a semicolon, including all of the statements inside the function. It is standard practice to indent statements within the function code block. Indenting helps to visually identify which statements belong to the function. You run a function by calling its name. In fact, you've already been running lots of functions in previous chapters, like setCookie and sessionStart. These are predefined in PHP, and you just have to use them. You can run the functions that you create in the same way. For example, to run the whatever function that we created previously, just call it by name, whatever, open paren, close paren. To create and call a basic function. The example code is taken from the menus.php file, script 10.1. It defines a function that creates drop-down menu items on a form. Notice that some of the code has been removed so that it'll fit on the slide. Look in the textbook for the full script code. Start with the function keyword. Then give the function a name. In this case, the name is make_date_menus. Then the parenthesis, then an opening curly brace, then the code statements, and finally the closing curly brace. Notice that the function matches the syntax we described previously. All functions must follow the correct syntax. The code inside the function can do whatever it needs to complete the task. In this case, it creates drop-down menu items. First, it creates an array of months. Then it prints an opening select HTML tag with the name month. Then it runs a loop for each month in the months array. Inside the loop, it prints the option HTML tag for each month. Once all months are included, it prints the closing select HTML tag. Look in the textbook for the rest of the function code. Now that we have a function defined, we have to run it to create the drop-down menus. Look at the code at the bottom of the slide. First, we print the opening form HTML tag. Then we call the makeDateMenus function. Calling the function here runs the code to create the drop-down menus in HTML. Finally, we print the closing form HTML tag. Technically, we didn't have to create a function and could have just put the function code between the form tags. Doing this would provide the same results. The drop-down menus would have been created in the form. But by creating a function instead, we have several benefits. The code is easier to understand. Since we chose a descriptive name, we can reasonably assume that the function will create date menus. We won't have to read through the code to get a general understanding of what it does. And we can reuse the code without having to repeat it. Just call the function again and again to create date menus. And we would only have to change the code in one place if modifications were ever necessary. Creating and calling functions that take arguments. The information that is passed to a function is known as arguments or parameters. Arguments are passed within the parenthesis after the function name. Look at the function syntax on the slide. It mostly looks like the syntax that we saw earlier, except this one shows arguments within the parenthesis. Arguments represent information passed to a function. Multiple arguments are separated by commas. You can see an example of a function with arguments on the slide. The function name is makeFullName. The function takes two arguments, first and last. The arguments are separated by a comma in the function definition. The function code prints the first and last name strings. As you might be able to tell from this example, arguments are really just variables. They are just like any other variables that we've been using so far. They have a name and a value, and you can use the values stored within the variables. In this case, the variables are first and last. The values stored in the variables are the information passed to the function. Inside the function, we can use the variable values in any typical way. This function prints the values. You pass information to a function in the arguments when calling the function. You can pass variables as arguments, or you can pass literal values as arguments. Either way, the values are passed to the function and stored in the argument variables. The order of the arguments matters. You can't pass arguments in any order. They have to match the order that they're defined in the function. Look at the example on the slide. The first argument passed when calling the function goes into the first variable in the function definition. The second argument passed when calling the function goes into the second variable in the function definition. This goes on regardless of the number of arguments. Passing arguments out of order will almost certainly create unexpected results, including errors. To create and call a function that takes arguments. The example code is taken from the sticky1.php file script10.2. It defines a function that takes two arguments. Start with the function keyword. Then give the function a name. In this case, the name is make_function. underscore text underscore input. Then the parenthesis. Inside the parenthesis are the arguments. In this case, two arguments, name and label. Then an opening curly brace, then the code statements, finally the closing curly brace. The code inside the function uses the arguments to create input HTML tags. First, it prints an opening label HTML tag along with the value of the label argument variable. Then it prints the opening input HTML tag with the name equal to the value of the name argument variable. Then it checks to see if there's a post element with the same name as the name argument variable. If so, it sets the value of the input HTML tag equal to the value in the post array. This is known as making a field sticky. It's setting the value of the input form element to a value previously entered, basically remembering the value so the user doesn't have to retype it again. Then it prints the closing label HTML tag. Now that we have a function defined, we have to run it to create the input text fields on the form. First, we print the opening form HTML tag. Then we call the makeTextInput function with two arguments. The first argument is the name of the input text field. In this case, first underscore name. This will become the name of the input HTML tag. The second argument is the label for the input text field. In this case, first name. This will become the label that is displayed on the web page for the input HTML tag. And finally, print the submit button and the closing form HTML tag. The function is called two more times to create a total of 3 input text fields on the form. When you run the code, you should see a page similar to the image on the slide. You have 3 text input fields. Each displays the label that was passed as the second argument for that text field. If you view the source for the page, you should see the name of each text field match the value of the first argument that was passed for that text field. Setting default argument values. In PHP, function arguments can have default values. To set a default value, assign the value to the argument in the function definition. If the value is passed for the argument, then that value is used in the function. If a value is not passed, then the default value is used in the function. Look at the greeting function on the slide. It includes one argument named who with a default value equal world. The function prints hello and then the value of the who variable. If the function is called without an argument, as in the first example, then the function uses the default value of world. So you see hello world. If the function is called with a value in the argument, as in the second example, then the function uses that value. In this case, Zoe. So you see hello Zoe. The arguments with default values must come after arguments without default values. You can see this in the calculate total function on the slide. The first argument does not have a default value, and the next 2 arguments have default values. When calling a function, you can't skip non-default arguments. The first argument in the function call maps to the first argument in the function definition. Whatever you pass as the first value will be stored in the first argument variable. Only arguments that have a default value can be left blank. To write a function that uses default values. The example code is taken from the sticky2.php file script10.3. It defines a function that takes 3 arguments, one with a default value. Start with the function keyword. Then give the function a name. In this case, the name is make_text_input. Then the parenthesis. Inside the parenthesis are the arguments. In this case, 3 arguments: name, label, and size, with size having a default value of 20. Then an opening curly brace, then the code statements, and finally a closing curly brace. The code inside the function is basically the same as the sticky1 script that we discussed previously. The difference is that it includes the size attribute in the input HTML tag. If a value is passed for size, then the size on the input field is set to that value. If a value is not passed for size, then the default size of 20 is used for the size of the input field. So the size will be set to the value passed, or to 20. Calling the function is also basically the same as calling the sticky1 script. The first time, only the name and label arguments are passed values. Since there's not a value provided for the size argument, the default value of 20 is used. The first input field will have a size equal 20. The second call passes a size of 30, so the input field will have a size equal 30. And the last call passes a size of 50, so the input field will have a size equal 50. When you run the code, you should see a page similar to the image on the slide. You can see that the size of the input fields are different. If you view the source for the page, you should see the size of each text field match the size of the size argument that was passed for that text field. Creating and calling functions that return a value. Just as it is possible to pass information to a function, it is also possible to return information from a function. To return a value, use the return statement within the function. Look at the function syntax on the slide. It looks mostly the same as we saw earlier, except this one shows the return statement. The return statement passes a value back to the function call. In this case, it passes the value stored in the name variable. You can see how the return value is handled with the examples at the bottom of the slide. The first one calls the makeFullName function, and the return value is assigned to the full name variable. You can use the full name variable like any other variable. The second one calls the makeFullName function and prints the return value. Since the return value isn't saved in a variable, it only exists while it is being printed. It doesn't exist after the print function is finished printing. The third one calls the makeFullName function and ignores the return value. Even though you would normally do something with the return value, this one shows that it is not necessary and can be ignored. To create and use a function that returns a value. The example code is taken from the calculator1.php file script10.4. It defines a function that takes 2 arguments and returns a value. Start with the function keyword. Then give the function a name. In this case, the name is calculate_total. Then the parenthesis. Inside the parenthesis are the arguments. In this case, 2 arguments, quantity and price. Then an opening curly brace, then the code statements, and finally the closing curly brace. The code inside the function uses the arguments to calculate a total. First, it multiplies the quantity with the price, and stores the results in the total variable. Then it formats the total with 2 decimals. And finally, it returns the value in total. Next, it calls the calculate total function, passing 2 values. The values are the quantity and the price taken from the post array. The return value is stored in a variable called total. The total value is printed on the page inside of paragraph and span HTML tags. Understanding variable scope. The scope of a variable is the context within which it is defined. It is the boundary that a variable exists and can be accessed from code. A global scope includes variables that are defined outside of a function. They exist outside a function and can only be accessed outside of a function by default. A local scope includes variables that are defined inside of a function. They exist inside a function and can only be accessed from inside a function. A global variable is different from a local variable, even if they have the same name. One only exists outside of the function and the other only exists inside the function. Look at the example on the slide. We see a function add1 that takes a single argument named n. In this case, n is a local variable within the function. The function increments n and prints a message. After the function declaration, we create a variable named n and assign the value 1. In this case, n is a global variable. It is created outside of the function. The n variable inside the function is not the same as the n created outside of the function. Then print the value of n. At this point, the value of n, the global variable, is equal to 1. We just set it to 1. Then call the add1 function to pass the value of n. Inside the function, we increment n, the local variable. Now, n is equal to 2, but only the n inside the function, the local variable. The n variable outside the function is a different variable and is still equal to 1. We print the value of n again, the global variable, and we see that it is still equal to 1. It is possible to access global variables from within a function by using the global statement. The opposite is not possible. You cannot access a local variable from outside a function. To access a global variable from within a function, include the global keyword in front of the variable name. Look at the example on the slide. First, we declare a global variable named var1 and assign a value of 1. Then, inside the function, reference the global variable var1 by using the global keyword. Without the global keyword, the var1 variable inside the function would be a local variable and completely different than the global variable var1. By using the global keyword, we are referencing the same global variable var1. Then we change the value of the global variable var1 to equal 2. Now the global variable var1 has a value of 2. Finally, we print the value of the global variable var1. You should see the value of 2 printed. If you were to print the value of var1 after calling the function, you should also see a value of 2. Let's try the previous example, but this time use a global variable. Look at the example on the slide. We see a function add1, but this time, instead of passing an argument n, it uses the global keyword to reference the global variable n. So the variable n inside the function is the same as the global variable n. The function increments n and prints a message. After the function declaration, we create a variable named n and assign a value of 1. In this case, n is a global variable. It is created outside of a function. Then, print the value of n. The value of n is equal 1. We just set it to 1. Then, call the add1 function. Inside the function, we increment the global variable n. Now the global variable n is equal 2. Finally, we print the value of n again, and we see that it is incremented to 2. To use the global statement, the example code is taken from the calculator2.php file script 10.5. It defines a function that takes 2 arguments and returns a value. This time the function uses a global variable for tax in the calculations. First, create a global variable named tax and assign a value equal 8.75. Then create a function with a name calculate_total. The function defines 2 arguments, quantity and price. The code inside the function uses the arguments and the global variable to calculate a total. Notice the global keyword before the tax variable. This makes the tax variable inside the function reference the global variable tax. Declaring the tax variable inside the function without the global keyword would create a separate local variable for tax. It performs the calculations, and finally it returns a value in total. Next, it calls the calculate total function and passes 2 values. The return value is stored in a variable named total. The total value is printed on the page inside paragraph and span HTML tags. Function design theory. Remember the following best practices when creating functions. Typically, a function will contain code that will be reused or called multiple times. This is to eliminate duplication of code. A function is not really necessary for code that will only be used once. However, you may choose to put single-use code in a function just for clarification, to make your code easier to understand. For example, if you had a very complicated calculation, you might choose to put that code in a function, even though it's only called once. That way the code for the calculation is separated from the other code and potentially easier to understand. A function should be a black box, meaning a programmer shouldn't need to know how a function works to be able to use it. In other words, you call a function and it works as expected, like all of the PHP built-in functions that we've been calling. We call them without knowing what's inside, but expect them to work as defined. A function should use global variables as little as possible. Using global variables makes the function dependent on information outside of itself. Instead, pass any information the function needs as arguments so that global variables are not required. Functions should be independent and not require any information from outside other than the information passed in arguments.